Hello everyone, welcome to my channel, and today I want to share something that really made me stand out during a recent job interview. System programming personal project that I built from scratch. So this project not only showcased my technical skills but also demonstrated my understanding of cloud architecture and the concepts of containerization. So during my job search, I noticed that many candidates had similar projects on their resume. So to do apps, basic CRUD applications, or simple websites, I wanted to do something that will spike a conversation with an interviewer, and I decided to build a platform similar to AWS Lambda, but at a very small scale. So the idea was simple. I was to create a platform that allow users to upload code as zip files, which will then be automatically containerized and executed on demand. This mimics how serverless platform work in the cloud, but in a self-contained environment that I will could demonstrate during the interview. So let me walk you through the architecture of this, the high-level diagrams, as you can see. So we had we have an API gateway function to a client application API gateway. So if we were to scale this, we would have that, and then the function execution environment, we have function storage, and then the container orchestration, and then monitoring and logging. So the flow diagram would be somebody uploads code in a zip file, we build a container, deploy the function, execute the function. We can monitor, update, and then delete the function afterwards. So on our serverless platform, we had the HTTP server with the request handlers, and then function management, code processing and containerization, Docker API, and then function execution. So on our API side, let me go to the exact code. The GitHub repository will be attached to this, and you can take a look. So we have our handlers, and as you can see, our handlers have, you submit code, you can execute, you can list functions, and then you can also delete a function by ID. We can check the health of our service. So this is what we have here, and on the Docker side, a lot of the interviewer asked a lot of questions on the Docker management side of things. Let's refactor that to the manager and also add manager there. So how are we creating the containers and all that, the security that we imposed. So I wanted to talk about this. So when our container is running, we don't give any privileges. So no new privileges. What it was set to run with, that was what is. So this helps to curb exploits. Also, we limited memory, and then we limited CPU. So this is just an example of what was written, but there are a lot of suggestions here. So during the interview, this project helped me demonstrate, first of all, system design, how all these components come together. I also was able to showcase my container expertise. I was able to create Docker containers using code on fly, security awareness by capping the memory, CPU, also not letting any new privileges inside the container. That helped. And Yeah. So during this, um, I was asked. These are a few questions that I was asked. So, how would you make this platform scalable for production use? So, there are a lot of ways. First of all, if we look at our store here, we are using an in-memory store, and you know this doesn't scale. So this one will, what will happen is we will lose data on restart. So this here can be replaced with a persistent storage like maybe DynamoDB, MongoDB, or Postgres if you love SQL. Also, we could implement container orchestration so that we could put something like Kubernetes to manage our containers so that they can scale in and scale out automatically. Right now, we are just spinning one container and all that. Those are the improvements we could do. But one really big improvement we could do is this is a synchronous process. So we could make it asynchronous. This is asynchronous, like it's linear. So we would make it asynchronous by introducing message queues and all that and all that, and it would have scaled well so that our client requests are queued and then executed uh, one by one, so that we don't get errors where we are executing a lot and our underlying machine runs out of resources. So I will continue improving on this project, and where I would want to improve is actually make it asynchronous so that our requests are queued, executed, and we get those back. That is what most serverless functions do, because you don't have unlimited resources. So I will do that. I will also um, add support for other languages. Right now it only supports Golang and all that, so I'll add support for other languages. But right now I think I want to give you a demonstration on how it works, if at all it still runs. So I have a make file with we can build, we can run build, we can, let's see if we can yeah. So test.zip, do we have test.zip? Yeah, so test.zip, this is a Python file, and it resizes an image. We give it an image URL and it resizes that. So we want to see if our container can actually run this. So what I'll do is inside the make file, we don't know the function ID yet, so I will leave that blank. But what I'll do is I will run a submit. I will submit this make submit. No, our server is not running, so we will run main.go and wait for it to start. Yeah, our server is now running, and we also implemented graceful shutdowns, which is really nice. So when our server is running, we can go and try and submit our test.zip file. So as you can see, our zip file was submitted well, and then we get a function ID, and then the image that was created, and then the deployment message, it was deployed successfully. So when we come back to our makefile and we replace this with our function ID, and now we want to execute. Now we want to execute that, so we run make execute. We get the output. Why do fish live in salt water? Because pepper makes them sneeze. Oh, no. So I think we submitted the wrong code. Yeah, we submitted zip, but we should have submitted image processor.zip. So let's submit image processor.zip. So our makefile just makes work easy for us. We could do this. We could do this just using curl. Yeah, so we have a new function that has been submitted, and then we replace the function ID here, and then we want to execute it. So we are executing this same function that is here. So we get, this is a binary, this is an image encoded in binary format. So what can we do to see it? Let's copy all this after up to what point? I think up to this point here. We can copy that, and then we can go to a browser. We can launch a browser window and try and look at the image. So before we do that, okay, yeah, so binary to JPEG. Let's see if that will work. And oh, I think this is still converting. Let's see. Let's look for another tool. No, that is the same tool. I saw a tool here. Yeah, base 64 to image. This one, yeah, this one worked for me very well. And then you decode base 62 4 to the image. Let's see. No, I think we copied think we copied it up to the wrong place. Let's see. Let's go back to our IDE and see what is wrong. What are we missing? So this is the original, and then this is the processed image URL. I think we are going to copy from there up to here. Then we go back here and check. Oh, what's wrong? Let's remove this trailing and this one here. Let's see. Yeah, so we had these invalid strings and characters. So I think now we can convert it to an image and see. Wow, what's going on here? Let's copy that and then we repair. After repairing, oh nice, after repairing we get the repaired, and then we come to base 64 and see the code to image, and then voila, you see our image transformation has occurred. So if we go back to our code and check, this image was from uSplash. Let's go and check this image and try and find it online. We'll see that we have this. Yeah, so you see our serverless architecture actually worked. So if you like to see more of such system programming tutorials, subscribe. And if also you like to see my journey, how I transition from cloud support engineer to SDE or sysdev engineer here at Amazon, if at all it will happen, please follow, and you can come along with me through the journey. Thank you.